consider is if you could travel back through time when the compatibility is not an issue, and you started Python all over again. Can you make the case for indentation still?
Well, it frees up a pair of matched brackets, of which there are never enough in the world, for other purposes. Really makes the language slightly sort of easier to grasp for people who don't already know another programming language. Because sort of one of the things, and I mostly got this from my mentors who taught me programming language design in the earlier 80s. When you're teaching programming for the total newbie who has not coded before, not in any other language, a whole bunch of concepts in programming are very alien or sort of new and maybe very interesting, but also distracting and confusing. And there are many different things you have to learn. You have to sort of, in a typical 13-week programming course, you have to, if it's like really learning to program from scratch, you have to cover algorithms, you have to cover data structures, you have to cover syntax, you have to cover variables, loops, functions, recursion, classes, expressions, operators. There are so many concepts. If you sort of, if you can spend a little less time having to worry about the syntax. The classic example was often, oh, the compiler complains every time I put a semicolon in the wrong place, or I forget to put a semicolon. Python doesn't have semicolons in that sense. So you can't forget them. And you are also not sort of misled into putting them where they don't belong because you don't learn about them in the first place.
The flip side of that is forcing the strictness onto the beginning programmer to teach them that programming is values attention to details. You don't get to just write the way you write an English
paper. Plenty of other details that they have to pay attention to. Yes. So I think they'll still get the message about paying attention to details.
The interesting design choice. So I still program quite a bit in PHP. And I'm sure there's other languages like this, but the $sign before a variable, that was always an annoying thing for me. It didn't quite fit into my understanding of why this is good for a programming language. I'm not sure if you ever thought about that one.
That is a historical thing. There is a whole lineage of programming languages. PHP is one, Perl was one, the Unix shell is one of the oldest, or all the different shells. The dollar was invented for that purpose because the very earliest shells had a notion of scripting, but they did not have a notion of parameterizing the scripting.
Right.
And so a script is just a few lines of text, where each line of text is a command that is read by a very primitive command processor that then sort of takes the first word on the line as the name of a program and passes all the rest of the line as text into the program for the program to figure out what to do with as arguments. And so by the time scripting was slightly more mature than the very first script, there was a convention that just like the first word of the line is the name of the program, the following words could be names of files. Input.txt, output.html, things like that. The next thing that happens is, oh, it would actually be really nice if we could have variables and especially parameters for scripts. Parameters are usually what starts this process. But now you have a problem because you can't just say the parameters are X, Y, and Z, And so now we call, let's say X is the input file and Y is the output file. And let's forget about Z for now. I have my program, and I write program X, Y. Well, that already has a meaning, because that presumably means X itself is the file. It's a file name. It's not a variable name. And so the inventors of things like the Unix shell, and I'm sure job command language at IBM before that, had to use something that made it clear to the script processor, here is an X that is not actually the name of a file, which you just pass through to the program you're running. Here is an X that is the name of a variable. Yeah. And when you're writing a script processor, you try to keep it as simple as possible. Because certainly in the 50s and 60s, the thing that interprets the script was itself had to be a very small program, because it had to fit in a very small part of memory. And so saying, oh, just look at each character, and if you see a $sign, you jump to another section of the code, and then you gobble up characters, say until the next space or something, and you say that's the variable name. And so it was sort of invented as a clever way to make parsing of things that contain both variable and fixed parts very easy in a very simple script processor. It also helps, even then, it also helps the human author and the human reader of the script to quickly see, oh, 20 lines down in the script, I see a reference to X, Y, Z. Oh, it has a $1 in front of it. So now we know that X, Y, Z must be one of the parameters of the script.
Well, this is fascinating. Several things to say, which is the leftovers from the simple script processor languages are now in code bases, like behind Facebook, or behind most of the backend. I think PHP probably still runs most of the back end of the internet.
Oh, yeah. Yeah, I think there's a lot of it in Wikipedia, too, for example.
It's funny that those decisions, or not funny, it's fascinating that those decisions permeate through time.
Just like biological systems, right? I mean, the sort of the inner workings of DNA have been stable for, well, I don't know how long it was, like 300 million years, 500 million years.
Yeah.
And there are all sorts of weird quirks there that don't make a lot of sense if you were to design a system like self-replicating molecules from scratch.
Well, that system has a lot of interesting resilience. It has redundancy that results, like it messes up in interesting ways that still is resilient when you look at the system level of the organism. Code doesn't necessarily have that, a computer programming code.
You'd be surprised how much resilience modern code has. I mean, if you look at the number of bugs per line of code, even in very well tested code that in practice works just fine, there are actually lots of things that don't work fine. And there are error correcting or self-correcting mechanisms at many levels.
Including probably the user of the code.
Well, in the end, the user who sort of is told, well, you got to reboot your PC, is part of that system. Yeah. And a slightly less drastic thing is reload the page, which we all know how to do without thinking about it when something weird happens. You try to reload a few times before you say, oh, there's something really weird.
Okay. Or try to click the button again if the first time didn't work.
Well, yeah, that we should all have learned not to do that, because that's probably just going to turn the light back off.
Yeah, true. So do it 3 times. That's the right lesson. So, and I wonder how many people actually like the $sign. Like you said, it is documentation. So to me, it's whatever the opposite of syntactic sugar is, syntactic poison. To me, it is such a pain in the ass that I have to type in a $sign. Also, super error prone. So it's not self-documenting. It's like a bug generating thing. It is a kind of documentation. That's the pro, and the con is it's a source of a lot of bugs. But actually, I have to ask you, this is a really interesting idea of bugs per line of code. If you look at all the computer systems out there, from the code that runs nuclear weapons to the code that runs all the amazing companies that you've been involved with and not, code that runs Twitter and Facebook and Dropbox and Google and Microsoft, Windows, and so on. And we like laid out. Wouldn't that be a cool like table? Bugs per line of code. And what would let's put like actual companies aside. Do you think we'd be surprised by the number we see there for all these companies?
That depends on whether you've ever read about research that's been done in this area before. And I don't know, the last time I saw some research like that, it was probably in the 90s, and the research might have been done in the 80s. But the conclusion was across a wide range of different software, different languages, different companies, different development styles. The number of bugs is always, I think it's in the order of about 1 bug per 1,000 lines in sort of mature software that is considered
Interesting.
as good as it gets.
Can I give you some facts here? There's a lot of really good papers. So you said mature software, right? So here's a report from a programming analytics company. Now this is from a developer perspective. Well, let me just say what it says, because this is very weird and surprising. On average, a developer creates 70 bugs per 1,000 lines of code. 15 bugs per 1,000 lines of code find their way to the customers. This is in the software they've analyzed.
I was wrong by an order of magnitude there.
Fixing a bug takes 30 times longer than writing a line of code. That I can believe.
Yeah.
75% of a developer's time is spent on debugging. That's for an average developer that they analyzed is 1,500 hours a year. In U.S. alone, $113 billion is spent annually on identifying and fixing bugs.
And I imagine this is marketing literature for someone who claims to have a golden bullet or a silver bullet that makes all that investment in fixing bugs go away. But that's usually not going to. Yeah, that's not going to happen.
Well, they're referencing a lot of stuff, of course, but it is a page. That is, there's a contact us button at the bottom. Presumably, if you just spend a little bit less than $100 billion, we're willing to solve the problem for you. Right. And there's also a report on Stack Exchange and Stack Overflow on the exact same topic, but when I open it up at the moment, the page says Stack Overflow is currently offline for maintenance.
Oh, that is ironic.
Yes. By the way, their error page is awesome. Anyway. I mean, can you believe that number of bugs?
Oh, absolutely.
Isn't that scary? That 70 bugs per 1,000 lines of code. So even 10 bugs per 1,000 lines of code.
Well, that's about 1 bug every 15 lines, and that's when you're first typing it in.
Yeah, from a developer, but like, how many bugs are going to be found? If you're typing...
Well, the development process is extremely iterative. Typically, you don't make a plan for what software you're going to release a year from now and work out all the details, because actually all the details themselves consist. You sort of compose a program.